Hello everyone and welcome to this tutorial on automotive sensors. Today's vehicles are much more than just mechanical machines. Modern automobiles have become intelligent systems that continuously monitor their surroundings, analyze operating conditions and make decisions in real time. Whether it is a conventional petrol vehicle or diesel vehicle, a hybrid vehicle or an electric vehicle, sensors play a vital role in ensuring that every system functions accurately and efficiently. Imagine driving a car without knowing the engine temperature, fuel level, wheel speed, tire pressure or battery condition. It would be almost impossible to ensure safety, efficiency and performance. This is exactly why sensors have been one of the most important components in modern automobiles. You may have surprised to know that an average modern passenger car contains more than 100 sensors, while premium vehicles and autonomous vehicles can have over 300 sensors. The sensors continuously collect information and send it to various electronic control units, commonly known as ECUs. That ECUs process this information and control different vehicle systems such as the engine, transmission, braking system, steering suspension, air conditioning, airbags and advanced driver assistance systems. In this video, we will begin by understanding the basic concept of automotive sensors and explore where different sensors are placed in various vehicle systems, including the powertrain, chassis, body electronics, and finally discuss the importance of electromagnetic compatibility, also known as EMC. By the end of this session, you will clearly understand how sensors enable vehicle to become safer, smarter, cleaner, and more efficient. So let us begin with the fundamentals of automotive sensors. Before learning about automotive sensors, we must first understand what is a sensor actually working. What is a sensor actually is? A sensor is an electronic device that detects a physical quantity from the environment and converts it into an electrical signal that can be processed by a controller or computer. In simple words, sensors act as the eye, ears, nose, and skin of an automobile. Just as our eye detects lights and our ear detects sounds, sensors continuously detect various physical parameters inside and outside the vehicle. Some of the common physical quantities measured by sensors include temperature, pressure, speed, position, acceleration, light intensity, humidity, gas concentration, vibration, and magnetic fields. Let us understand this with a few simple examples. A thermometer measures temperature, a weighing machine measures force, a smartphone adjusts its screen brightness automatically using a light sensor. Similarly, automobiles use hundreds of sensors to monitor engine performance, battery health, and braking systems, steering systems, airbag deployment, and many other vehicle functions. However, sensors do not simply measure physical quantities. They also convert those measurements into electrical signals such as voltage, current, frequency, or digital data. These signals are transmitted to the electronic control unit, that means ECU, where they are analyzed to make intelligent decisions. For example, if the engine temperature becomes too high, the temperature sensor immediately sends to this information to the ECU. The ECU then activates the cooling fan or displays a warning on the dashboard to prevent engine damage. Likewise, if the oxygen sensor detects improper combustion, the ECU adjusts the fuel injection system to improve combustion efficiency and reduce harmful emissions. Without sensors, modern vehicles would be unable to monitor their own conditions, respond intelligently to changing driving situations. This is why sensors form the foundation of every modern automotive electronic systems. How that we understand the sensor, how that we understand what is a sensor, let us see where sensors are installed inside the vehicle. The first major system is the powertrain. The powertrain consists of all the components responsible for generating power and transmitting it to the wheels in a conventional vehicle. This includes the engine, clutch, gearbox, drive shaft, differential, and wheels. In an electric vehicle, the powertrain includes the battery pack, inverter, electric motor, reduction gearbox, and differential. Since the powertrain is responsible for vehicle movement, it requires continuous monitoring using multiple sensors. Some of the important sensors used in this powertrain includes: first one, the crankshaft position sensor. It measures rotational speed and exact regular position of the crankshaft. This information is essential for ignition, timing, and fuel injection. Next, the camshaft position sensor. It detects the position of the camshaft so that the ECU can precisely control valve timing. Next one, oxygen sensor, also called lambda sensor. It measures the amount of oxygen present in the exhaust gases. We can use this information. The ECU adjusts the air-fuel ratio to improve combustion efficiency while reducing emissions. Next, the knock sensor. The knock sensor detects abnormal combustion or knocking inside the engine cylinder. If knocking occurs, the ECU immediately adjusts the ignition timing to protect the engine. Next one, MAF sensor, or manifold absolute pressure sensor, measures the pressure inside the intake manifold. This helps determine engine load and optimize fuel delivery. Next, the MAF sensor, or mass airflow sensor, measures amount of air entering to the engine, allowing the ECU to inject the correct quantity of fuel. Next one, the coolant temperature sensor. The sensor continuously monitors engine temperature to prevent overheating and improve engine efficiency. And finally, the transmission speed sensor. It measures gearbox speed and assists in smooth gear shifting in automatic transmission. Together, these sensors continuously monitor engine performance and ensure maximum power, better fuel economy, lower emission, and improved reliability. Now we are going to see about sensor placed in powertrain systems. First one, sensor, crankshaft position sensor. It is located engine. It measures a crankshaft speed and position. Likewise, next, camshaft position. It is located in cylinder head and in the function control valve timing. Next, O2 sensor. It is located exhaust manifold. It measures oxygen level of the airflow ratio. Likewise, an ox sensor, MAF sensor, and MAF sensor, coolant temperature sensor, transmission speed sensor. These are all located in like engine block, intake manifold, air intake, engine jacket, gearbox. These are the functions of sensor which are placement in powertrain system. Sensor placement in powertrain systems. All the sensors are located and mounted is as shown in figure. Thank you for watching.